Welcome to this screencast that I'm putting together to help you understand an Excel visualization of the single layer model discussed in the week 5 lecture. So to start, we need to open the Excel spreadsheet. Note that this Excel file has an embedded macro, and we will need to enable macros on startup. Just going to maximize this window and perhaps make the text a little bit bigger. Okay, great. With this spreadsheet open then, we can see a graphic in the center here, and this will be familiar from the lecture itself. We have the various radiative fluxes into and out of the Earth system and how they interact with the atmosphere and the Earth surface. The temperature of the Earth's surface is reported here, as well as any change to the temperature that might result from altering any of the parameters from their default values. At the top, we have the solar flux into the Earth system that accounts for the solar constant and the Earth's albedo. This solar flux is reduced by a factor tau S that accounts for the absorption of solar radiation by the atmosphere. The Earth's surface itself emits radiation. This ground flux is entirely dependent on the Earth's surface temperature, and as we learnt in the lecture, the Earth radiates heat in the infrared part of the spectrum, whereas the solar spectrum peaks in the visible. The atmosphere has molecules in it that are very efficient absorbers of infrared radiation, such that only about 10% of the infrared radiation emitted by the Earth's surface passes through the Earth's atmosphere and escapes into space. The rest is absorbed by the atmosphere. The atmosphere itself radiates energy and does so back to space, as well as back towards the Earth's surface. In this top left panel, we have the parameters that we can change to see their effect on the Earth's surface temperature. These parameters are the albedo, the fraction of solar flux that gets through the atmosphere, and the fraction of the ground flux that gets through the atmosphere and escapes to space. If we change the albedo from its default value of 0.3 to say 0.25, what would we be expecting to happen in our single layer model? Well, we would expect more solar radiation to be absorbed by the Earth system and for the Earth therefore to heat up. So let's do that. You can see that indeed the temperature does increase and increases by about 5 Kelvin. You can also see that this is because the solar flux is larger. This change propagates through the entire Earth system, resulting in a larger ground flux and ultimately a larger Earth surface temperature. You can see that the changes to each element in the single layer model have been represented by changes in the colors to the arrows. So red means that the associated flux has increased, and blue, not seen in this change, would mean that the associated flux has decreased. We can see a decrease in some of these fluxes if, for instance, we decided to, increase the transmission of infrared radiation. So make the tau G parameter bigger. Okay, what would we expect? Well, such a change would happen if, for instance, we decrease the amount of carbon dioxide in the atmosphere, and I think we would expect the temperature of the Earth's surface to decrease. So let's do that. First, we'll change the albedo back to its default value, and then we can increase tau G to 0.15 from 0.1. Indeed, we now do see a drop in the Earth's surface temperature. We can also diagnose why we got this drop in Earth's surface temperature. And you can see that it's largely come about because more of the ground flux has escaped to space, which means less of the radiation from the sun has stayed in the Earth system. Okay. I think the important thing to note when you're playing around with this single line model is that the mathematical model that has been incorporated in this Excel spreadsheet is exactly the same as the model developed in the lecture. What this means is that you can use this model to investigate the effect of changes to the Earth system. For instance, you can predict what the effect on temperature will be due to, say, a volcanic eruption, such as the Hunga Tonga eruption we saw in early 2022. You could account for changes in albedo due to polar ice caps melting or to changes in greenhouse gas concentrations. You can also use this spreadsheet to help answer the quantitative questions that might be posed in wiki quizzes or indeed in block tests. So please have a play around and see if the model does what you expect. Thanks for listening.